So I'm the guy that created this thing called Sails.js, and I'm going to keep it pretty non-technical until we get to the questions and answers, and then you guys can get as technical as you want. But what actually how I met Freddie and Christian originally was through Y Combinator for a company called Treeline, which is sort of the next level on top of Sails.js. So if Node.js is like the crunchy nougat wrapper on the inside, and then Sails.js is like the chocolate, and this is like the nice little metal wrapper that puts it all together. So what I'm going to talk about primarily is what is software in the first place, right? How many of you guys have developed for the web or for mobile before? And probably all through Platzi, right? Awesome. So it led me down this direction after building the framework because I kind of found myself in this situation where everyone needed to make different plugins, right, for the framework, because inevitably with any piece of software, you need to customize it. You need to tweak it just a little bit. And this forced me to completely drop into this existential crisis and try to figure out what I was really doing. And I was wrong about a lot of things in Sails.js, but what I discovered was that software is a lot like planning, right? And it's kind of like planning, and it's kind of like creating your own universe. So whenever you sit down to write code, part of the reason that so many of us love it, I think, is because you get your hands on the keyboard, and you are now like a little god, right? This is your world, and you're able to do whatever you want. And that's really great, and it can be a really effective way to make stuff happen. But once you have more than one developer, you start to get all these tiny little universes, right? And even if you work together and you go through great pains to make your software reusable, a lot of times you end up with these completely different universes, right? Like one maybe is like a icy cold universe, and then another one is like salamander fire hell universe, right? And maybe one is PHP. And so I like PHP though. So anyways, the point is your users have to live in this universe that you create. And what really matters is whether they're happy, not so much what the universe actually looks like. So here in this example, let's say this is Magento, right? On the right, or stage right here, and then WordPress on the left. And they're pretty different, right? And they do different things. Magento is like e-commerce, shopping cart. WordPress is kind of for blogs, but sometimes for websites too. And then, that was kind of the first wave. Then in 2004, you ended up with Ruby on Rails, right? And you started to get all these very similar different frameworks. You have Django, or Grails, or Laravel, CakePHP, CodeIgniter, the list goes on. Sails.js, right? And they all look kind of similar. They all do basically the same thing, but they're all slightly different. And the way that these things work is they have models, views, and controllers. And that's kind of just an arbitrary way that it got set up that was effective. And there's no reason particularly why this is better than any other approach. It's just that everybody uses it. It's conventional. And that's what really matters. So let's pick this apart a little bit. This can mean a lot of different things, right? You've probably heard of this term before. Models can mean your database. It can mean some data. It can even mean an API sometimes. Views, a lot of times, is HTML, like a web page. Or it can be an iOS app. And then controllers are like the business logic, the plan, how the thing actually works. So back when Ruby on Rails first came out, you mainly cared about kind of this JSON or XML structured data, like your configuration. Then you had HTML that you used for your web page. And then for your code, you maybe had Java or C#, C++, or Ruby. Then, fast forward almost a decade. And now suddenly we have mobile, right? So now we have to worry about an iPhone app and an Android app and iPads and all this stuff. And luckily, XML started to kind of fade away a little bit for some of us, right? A lot of us still have to deal with it. And there were more languages than ever. There's Go, there's Dart coming out. So when I created Sails in 2012, it was sort of a reaction to this, right? And it was because whenever I sat down to create applications, I'd used Grails, I'd used PHP, I used Zen to CakePHP. I realized that you don't really, it's different now, right? You might want to use Angular.js or Backbone or Ember or React.js on the front end. And you might need to support a mobile app and a mobile website and a normal website. And this changed everything. So it allowed us to simplify stuff, actually. The back-end part got simpler. So now you really only have to worry about this kind of JavaScript data format. You have an API that everything can use on the front end. And then you have JavaScript, the language, which is this glue, right? And sort of the instructions that tell your code how to work. And basically, when we write software now, we almost always use frameworks, right? And we're really only specifying two different kinds of things. You have actual code, right? So in the JavaScript world, this is the JavaScript itself. And then you have JSON, right? Or you have data, which is kind of how you configure stuff. So you can specify like a password, right? Or a key as data. You might specify some markup as HTML. That's data, right? And then for your logic, you're going to write that with if-then statements, for loops, stuff like this. So we call that imperative code, right, versus declarative. Now, the thing about imperative code is that, and I realized this with Sails.js, like you can make just about anything be configurable as long as you have like a flag or a string or a number, right, that you can use to represent it. But with code, suddenly it's like this impenetrable barrier, right? You can't, it's not something you can like drag and drop to create. You have to actually write code by hand, or at least you used to have to. So here's an example. And this is, don't worry, it's code, but it's not really code. It's just pretend, okay? So step 1, drive to the store, right? Step 2, get milk. Step 3, go through the checkout and pay. Step 4, drive home. Step 5, put milk in your home refrigerator. So does anybody see what's wrong with this? There's a lot of things wrong with it, frankly. So one thing in particular is that the drive to store step, right? You can just keep breaking these apart more and more. So driving to store is actually walking out of your house, maybe putting on your shoes, right? Getting into the car, steering your car, pushing on the right pedals at the right time, not getting in terrible car accidents, right? Then getting out of your car, walking into the store, opening the door, right? You can get as deep as you want. And this we call it like a semantic hierarchy, right? So you have these different levels of meaning. And you can just dive deeper. And the problem is when we write code, if we write drive to store, it's now this huge impenetrable blob that we can't break apart. Now, if we wrote walk out of house and we wrote get into car or steer, then we could actually string those together, right? And a lot of times we call those functions. Now, the only problem with that is what if you do get a car accident, right? Or what if you forgot your wallet? So maybe when you go through the checkout and try to pay, you realize, oh, I don't have my wallet, right? So now, if you just try to drive home, you wouldn't have been allowed to take the milk. And then when you get home, you can't put the milk in the refrigerator because you don't have any milk. And this is how the snowball effect, right? It just keeps getting worse and worse and worse every step until your program's crazy and there's like hackers and your data's flying around. It's terrible. So another way to think about this same thing is what if every single step, every single line of code could have multiple outcomes, right? Because that's how reality works. Like I could trip and fall right now on the stage like this. And that would be different, right? I could drop the mic and it would make a lot of noise. But that didn't happen, and that's a different parallel universe, right? So if we forgot the wallet, we would want to put the milk back, drive home, get the wallet, and then drive back to the store. So if this was an API, a server, that's a business requirement, right? And that's something that, let's say I'm building your app for you, right? I'm just some random developer, and I have no idea what you would actually want to do if you forgot your wallet. Yet I'm the person making this up, because a lot of times the people that come up with the requirements don't have the mental model or don't have the resources to kind of go through every single step and figure that out. So if your credit card was expired, maybe put the milk back, drive home, and then just cry a little bit because you're never going to be able to get any milk again. So this was the big revelation moment for me when I figured this out. And 40 years ago, we had go-to statements. 40 years ago, then subroutines, right? Did anyone ever use BASIC? Okay, yeah, a few people. So BASIC had goto, right? And it had like go_sub. And go_sub was like the ancestor to a function. You would go to a line number, and you would number your lines like line 10, line 20. So that way you would have extra space in case you forgot something, and you could make line 15, right? So subroutines were great, and they let you have a return value. But it was hard to pass stuff in. You had to use everything global. Functions made this a little bit better because now you had arguments, right? And in some languages like Java or C, you could actually have typed arguments. So you would say, okay, that milk is going to be type milk. It's not type kerosene. Don't drink that. The next step in this evolution is that instead of there being functions that have typed arguments and then just one outcome, right? We need to make it more like the real world. And at every single step, there's actually parallel universes that could have occurred. Because I might have forgotten my wallet. And if we don't recognize that, we're never going to be able to build software that's truly reusable, and we're never going to make code go away. And I love coding, right? But I want to see it pocketed. I want to see it go away. Because what we get out of code is the creativity, right? We get to build this universe. And whatever that ends up looking like, it's still going to be some kind of code-like abstraction. But the really annoying part is when you're sitting there at 3 o'clock in the morning debugging a missed comma, right? Or you used one equal sign instead of 3 equal signs. Or worse, 2 equal signs instead of 3. So the way that programs get parsed in just about every language, whether it's an interpreted language like JavaScript or a compiled language like C, is you have this thing called the abstract syntax tree. And that sounds like complicated, but really all it is like, okay, here's some code. Let's take that, shake it around a little bit, and now it's kind of dangling it by a string, right? And now it's kind of bouncing around. And then we take that and we compile it into something else. And for your computer, it compiles it into this assembly language kind of instructions. And each one of those instructions is actually just a bunch of ones and zeros. And your processor happens to know how to handle that. And that's it. It's not very complicated. It's just we've gotten so far abstracted from that when now we want to go back and think about how can we make our program more like a tree again, we have to do a little bit of thinking. So what this can solve for us is never having to worry about plugins again, which is kind of a jump, so bear with me. And the reason why this is because if you do things this way, every single function is a plugin, right? And it's compatible with everything else because you know out of hand exactly what the inputs and the exits are. So if we know, right, if the buy milk function knows that it's possible that you'll forget your credit card, then you don't have to worry about it. You're forced to think about that before you ever even run your program. And it's kind of like typed exceptions in something like Java. But the difference is that there's no way out, right? You have to deal with it. So that's what I've been working on for the last, 2 years on top of Sails.js. And what it's called is the Node Machine project. And this is just for one language right now. Eventually, it will be for more languages. But for JavaScript, you can tell a function, hey, these are my inputs, these are my exits, and now that function is self-aware. That function knows what could happen afterwards. And by doing that, it's like this little jellyfish thing, right? You can take those things and chain them together, and you automatically generate documentation. And you know that the software will never break. There will never be bugs. Because as long as you trust that code on the inside, once one person writes it and you trust it, you never have to worry about writing glue code around it again. So to go back to our example, here, because we know that credit card expired, we're never going to end up in that situation where we go home and we try to put the milk away and we realize we have no milk, and then we crash and drop the database, right? We don't do that anymore. So this achieves 3 huge things. One is interoperability, which is, think of USB, right? Or think of the fact that you can put a DVD into your computer, no matter who it's from. Or that you can play an MP3, right, on any kind of MP3 player. That's missing in software right now. The other is accessibility. So even if I'm on stage and I'm playing the violin, I may be an expert violinist, right, which I'm totally not. But let's say I was. that doesn't mean that I have to know who wrote the music I'm playing, or why they wrote it, or the very particular kinds of things they like to do in their source code. Like if you fork Sails.js on GitHub, you'd have to understand how I did things. But you can read sheet music, and you can understand what it does and how to play it. Just like you can use a toaster, by the way, right? You don't have to know how a toaster works. You just put the toast in there and press down on the little thing, and out pops the toast. Right? So the other thing this allows is, right now, whenever we build code, even if we start from a framework, we spend all this time reinventing the wheel and doing the same thing over and over again across every different app. And I've interacted with about 100 different apps, most of them Sails.js apps now in my relatively short life. And every single time, the login system took me, at least a couple of hours, right, to get right, to make sure it's good, and to customize it just a little bit for the project. But imagine if we didn't have to mess with that, and imagine the kind of tooling we could have tomorrow, right, in the next generation, and imagine how easy that would make it for people who have never programmed before. Or imagine having a technical manager, or even like a CTO or a CEO, be able to look at the code, right, and understand what it's doing without having to ask you. So, by the way, this picture is sort of the very, very first CAD system. This is a 1962 computer, and that thing he's holding is called the light pen. And this actually ended up turning into what we now think of as like Illustrator, right, or SVGs. And this is Rachel from our team doing the same thing for software. So the way that you build Sails.js apps or Ruby on Rails apps right now is you write code in a text editor, and then you run it, right? With Sails, you run Sails lift. But another way to do the same thing now is that you can drag and drop these standardized components together, and that generates code, and then you can run that code. Much in exactly the same way that you can write C code, the compiler turns that into assembly language, and then that gets fed into your computer. And the other thing about this, and here's the fear of failure part again. So you can see that because these things are modular, and because they aren't necessarily anything other than, it's like sheet music for your software, you can actually just change it to be whatever you want, right? You can give it labels, and you can make it make more sense to you. Because regardless of how hard it is to be a programmer right now, even, it's, I think 0.2% of the world's population can write code. And out of that, a tiny fraction of people can actually write scalable server-side code, right? And out of that, how many of those people are familiar with English as their first language, right? Probably a lot, because it's really hard to learn, because you have to go and understand, what if you don't know what the word if means, right? Or you don't know what the word for means. It's this additional barrier to entry. And I think that what we have now, the generation we're in, is the potential for everybody else in the world who might not even speak English at all to be able to participate in programming without having to spend a few days learning how to read the documentation. So this is what we call a circuit in Treeline. And this first part here is buscar un usuario, which is finding one user from the database. Then if that works out, it's going to verifique la contraseña, which is to check the password. And if that works out, and the password does match, right, that was provided, we're going to salvar a la sesión, and that's going to save it back to the session. So this is login, right? And this is pretty much most apps login. But the great thing about this is that if you copy this into your project, you can change the labels. And if you want to change the behavior, you don't have to know anything about code. All you have to do is drag and drop some additional pieces or change the configuration of these pieces. So back to what we talked about at the very beginning, functions, code, imperative code was this impenetrable atomic thing. But what we're solving is trying to turn that into something that's declarative, something that is just like data, just like everything else. And once we've done that, that means that everything can be configuration, right? There's nothing that's impenetrable. And it also means that instead of basically going through writing the code, testing manually if the code works, changing the code to make it work, testing it again, doing that 20 more times, Then writing documentation, if you're lucky to have time for that, right? Writing automated tests, if you're lucky. Deploying it to the server. Having the tests fail at some point. Going in, fixing the test, right? Updating the documentation. All of that goes away. And all you have to think about is design. And that's the future of programming. So, thank you.